So this series is about the natural logarithm. Now, when you're doing the natural logarithm, actually, how it is different from the normal exponential relation. Now, when you have a simple, let's say, a to the power x is b, this is your general exponential relation. Now, what happens is that if this base e is a special number, something called as e to the power x is b, this is the Euler's number. So this number plays an important role to decide or like do the calculations when you have logarithm base to the e. Now, how do we do this? So when when you have log x to the any base a, and if a is the number e, for example, log x to the base e, it is referred specifically as ln x out here. Now, like when you have like log x to the base 10, okay, this is actually log x, you sometimes hear right. Now, so if it is written as ln x, by default, you consider that this is nothing but log x to the base e. So now the properties of ln, that is actually how does the property change? So for example, if you got e to the power x is b, I can take x is actually ln b. This is what you got to remember, that okay, backwards and forwards both ways. So if you got like, let's say ln e to the power x equals to, let's say 3, my answer for x is ln 3. If I got, let's say, x e to the power 2x minus 1 is 5, 2x minus 1 equals to ln 5. So straight away you can remember. And how is it coming, So let's just take the properties of natural logarithms. If I got ln 1, it is going to be always 0. If you got ln e, it's 1, because it is actually, this is nothing but log e to the base e. So it is obviously has to be 1. If you got, let's say, log x to the base e minus log y to the base e, it's like ln x minus ln y. Actually, it is. I'm just writing backwards property. It is ln x over y. So if you got ln x times y, the properties remain the same. So ln x plus ln y. The only thing is that while you're problem solving, just be careful with the base e. So if you got, like, for example, ln x plus 1, ln x plus 2 is, let's say, 3, then how do you solve this? So if you got ln x is a, then x is actually e to the power a. So you got to remember these. Sometimes they become confusing. So x plus 2 is e to the power 3, and you get x is nothing but e to the power 3 minus 2, which you can find out exact value using your calculator. So let's take some examples now. So for example, if you wish to simplify, let's say ln e cube x square over y cube. So this is if I wish to simplify, and you know that your ln x is a and ln y is b. So you got to write down this answer, this expression that I'm writing in terms of a and b. So what you got to do here is that I can write down this as ln e cube plus ln x square minus ln y cube. And this becomes 3 ln e plus 2 ln x minus 3 ln y. So this is nothing but 3 plus 2 ln x, which you got, which is 2a minus 3b. So 3 plus 2a minus 3b. So this is the answer for this expression. Now if I got, like, for example, let's say, can I write down, let's say, log 5 to the base 3 as, if I write down the different base, so the change of base rule as I discussed previously, log a to the base b can be written as log a to the base c, or log a to the base c, or log b to the base c. So if I put the base e here, I can just put it as, okay, log 5 to the base e, or log 3 to the base e, so which is ln 5 over ln 3. This is sometimes required for standard level. So in short, if you remember this, okay, log 5 to the base 7 is also equals to ln 5 over ln 7. Also, you should remember that if you have got log a to the base b, in general, it is equals to log a over log b. Any bases you can take. I mean, it's a change of base rule eventually, putting the base 10. So this is how you do the basic properties of the natural logarithms. Now we'll cover up the graphs and the let's say log properties of the graphical exponential functions.